Hi folks, Jack from Smoky Mountain Scientific here, and today I want to talk about a feature that we have in our software for our spectrometer, the WheeTrometer, and specifically I want to talk about calibrating the wavelengths for the spectrometer. Okay, to do this we need to have a data set, and it needs to be collected with one data point averaging so that we get full 3600 data points across the baseline. And we could record that, but I've done this beforehand, so let's load the calibration demo spectrum. So there's the calibration demo spectrum. This is the spectrum that you get when you record a compact fluorescent light emission. Okay, we're going to use this because it's the spectra, the wavelengths are well known. We're going to hit the calibrate button down here, and it's going to give us a list of wavelengths and a list of pixels, right? So first thing we have to do is make sure that we have all of our pixels. And these are the wavelengths for compact fluorescent light. If you want to use a different wavelength set, then you'll have to you'll have to enter that information into a calibration file, and I'll talk about that at a different date. All right, so what we have to do is we have to make sure that the pixel number that goes with a peak is the correct pixel number. So we're going to zoom in on a peak, and let's take this medium-sized one there. Okay, this is the second peak. There's the first one there. Here's the second one. Second peak should be at 435.8, pixel number 1023. Okay, so we're going to zoom in on that peak, and we're going to select that peak, and we're going to tell the program to find the pixel number. So you hit the pick button, and it picks the pixel number, the highest point in the zoomed region. All right, so I have done this previously for each of these peaks in this particular spectrum, so all of the peaks should be correct. Okay, once we have all our pixels picked, I guess I should go through and show you which peaks go with which listing here. The first peak is this one. It's at 404.6. Second peak, as we said, 435.8. The third peak, we're going to skip this broad one. We're going to skip that one. We're going to take the highest peak in the spectrum. That should be at 546.1 nanometers. The next peak on the list is 611.6. That's this one. The final peak is down here, which is at 631.1 nanometers. Alright, so we're going to select all of the peaks that we want to use in a least square refinement. The model used here is a linear model with a sign correction. Okay, so sign function correction. Alright, so we have all of our peaks selected. We're going to hit the calculate button, and what's going to happen is it's going to shift the baseline. The spectrum will stay the same, but the baseline will adjust so that the spectral maxima will align with the wavelengths that they're supposed to be at. So let's do that, hitting the calculate button. Boom, things have now moved, and we have our corrected baseline. Alright, so let's zoom in on that guy and see where he is now. Zoom, should be at 435.8. That's 436, that's 433. Let's zoom it a little more. Let's get that a little closer. Get this one a little closer, hit the zoom button again. And you can see that 534, 535 will be here, 535.8. Might be a little off, but not by a lot. Okay, we could look at any of the peaks that we wish to. We could look at the little guy down here. and it should show up at 404.6, and there's 405. That looks pretty good. Anyway, that is how we calibrate our wavelength data for the WheeTrometer. And pretty soon here I'll have the save button working, so you'll be able to save the wavelength calibration file that you just created. I haven't quite gotten to that in writing code at this point, but that's going to be pretty soon here. All right, thanks for watching.